Good afternoon, everybody, and thank you for coming to the talk. Much appreciated. I hope you're having a good time in the Warrington show. It's the first time we've been here, but it's felt like there's been a nice buzz in the hall. So hopefully it's a fun show for people. Today I am going to be demonstrating on one of our Hydra computers, but much of what I shall be talking about applies to any of our modern range of RISC OS computers. We've tried to standardize things as much as possible across the range for the current generation. So basically, we have a sort of similar feature set across the Mini Pi at 199, all the way up to the N.Ex.T boxes at 399, and the Hydra at 599, and even onto things like the Pinebook Pro laptops. So what we've built is a range of computers with a lot of shared features and technologies. And we call this Project N.Ex.T, which I've been talking about one way or another for the last 12 months. And today I shall be showing you the fruits of Project N.Ex.T and what it actually means in real-world use. Before I do so, I'll just give a little recap on some of the software releases that we've done for R-Comp over the last few months, really sort of since Wakefield last year. Essentially, four bits of software. Most recently, we've done a update to Photodesk, Photodesk 3.24. That contains nearly 80 new updates and improvements. A lot of these came from going through the new manual that we produced last year, and the person who did the manual noted down all the sort of oddities and features and things that he was frustrated by and came across whilst writing the manual. And this has led to these 80 new changes in 3.24. So Photodesk 3.24 launched a few weeks back, and it's a free update to anybody who's bought the anything sort of 3.18 onwards from Pling Store or from the R-Comp stand. There's a no-quibble £29 upgrade from any earlier version, however you got it, even if you sort of brought it home from school with you one night. Don't ask any questions. £29 upgrade, and once you're on the £29 upgraded version, all the upgrades from then on are free. Subject to, I mean, if a version cost me a lot of money to get developed, then subject to change, but within reason, free updates going forwards on Photodesk. So this is about, think about the 6th release we've made of Photodesk since XAT took it over a few years back. So it's back in active development. Photodesk provides, let me see if we've got it in the graphics folder. Oh no, there it is. There it is. So and basically Photodesk provides image processing and sort of Photoshop-y type facilities for RISC OS, and it provides a wide range of import and export facilities, and there's been quite a few improvements to the import and export in the latest version. We've added support for modern file formats like QOI and WebP, I think. Yes, WebP, Google Web formats for images in the latest builds. So basically, Photodesk continuing to evolve and develop, supports all the latest machines, including, again, some of the improvements we've made recently to do with supporting large memory configurations, so it works quite happily on 4 gig RAM machines now. And as I say, free upgrade if you've already bought it from us. If not, £29 upgrade from any previous version. Second program to talk about is we launched sort of back end of last year, called Monitor Tools. And basically this brings together all of our various sort of monitor-related projects that we've worked on over the last sort of 5, 6, 7, 8 years for the different computers that we've designed, and brings it all together into one release. Plus, the headline feature of it is support for high refresh rate screens. So you can now, when you buy a monitor, it's quite normal now for monitors to exceed the sort of 60 frames a second that you traditionally see historically with LCD monitors. So where previously you would sort of get 60 frames a second, it's now common to get well north of 100, even north of 200 or 300 frames a second on your monitors. And what we found was that RISC OS, the auto detection didn't always work particularly well with high refresh rate monitors. So for example, I bought a lovely big monitor for testing, and it would only sync at 30 frames a second, despite being capable of 175 frames a second. So what I've done is to develop custom monitor definition files for high refresh rate monitors that supports all these high refresh rates at high resolutions for monitors. And what we found was that by generating custom modes, we were able to get much better results. So that monitor that previously would only do 30 frames a second now runs at 95 frames a second. So that's more than 3 times smoother. So when you're dragging windows around, the machines feel much more fluid and responsive. If you think about it, you've got this much faster computer, but it's still drawing the screen and refreshing the same rates that it did 20 years ago. So it's nice to have the smoother, more responsive displays. So that's supported with a range of custom monitor definition files for a range of different machines, obviously Raspberry Pi, but there's also ones for IMX6, virtual Acorn machines, I guess by extension RPCMU. There's ones for Beagle boards, Panda boards, RK3399, basically the whole range of systems we've got the custom monitor definition files for. Plus there's a whole load of utilities on there, like our for titanium users, there's the dual monitor support. For laptop users, there's USB video support, so you can plug in a monitor via a USB video adapter. There is automatic recovery from bad screen modes. If your monitor can't display the screen mode properly, it can recover out of that. So basically, lots and lots of monitor-related software, and that's £14.99 for the whole kit and caboodle. Going back in time a wee bit more, last summer we launched something called Clock Save. This is just a cheap £5 thing. And what Clock Save does is it solves the problem of many of the development boards like Raspberry Pis not having real-time clocks on the things. And what it does is when you shut your computer down, it stores the time, and then when you turn the computer on the next time, it will restore that time plus a bit to ensure that you always have a sensible time. So rather than defaulting back to 1970 or jumping to 2100 or what have you, you always have a fairly sensible time. Then once it's powered up, it will periodically sync with the internet, and it also avoids various problems with the existing NetTime module by restarting that and resyncing it whenever your internet connection comes up and down. So you're guaranteed to have the most accurate time you can. Now you say, what's the point in that, Andrew? One word for you, SSL, secure sites. If you don't have an accurate time on your computer and you visit a website that's encrypted, and that's pretty much all of them now, you only have a small window for the security certificate of an encrypted site. And if your computer is too far back or too far in the future, you just get nonsense back. You just don't get anything back. So it's imperative that if you want to have a working internet, you need to have a working real-time clock, and an accurate one, not just one that's any old time. So ClockSave solves that for pretty much any RISC OS machine. I've even deployed it on some of the RISC PCs in the office where the real-time clocks have died, the batteries have gone all wibbly. And ClockSave basically ensures that those RISC PCs behave correctly. So useful little bit of software, and it's just a £5. And finally, on the software front, we've got new Messenger Pro 9.03. That's a free upgrade to anybody with Messenger Pro 9. And the main changes there are two changes. Firstly, somewhere along the line, IMAP support had been we'd basically broken some aspects of IMAP support, so those have been fixed. And the other thing we've done is handling a custom tag called sender that is required by some internet providers. Messenger can now keep the sender in line with the email address, so that if internet providers require specific senders in order to pass the emails through their SMTP services, Messenger Pro can now sync that on a per box basis to ensure that everything goes smoothly. So it's basically just ensuring that Messenger continues to work well with as many internet providers as possible, in as many ways as possible. So those are our most recent software releases. We also did updated ports of the Heretic and Hexen video games last summer. So if you've got any interest in playing games on RISC OS, check those out because they've been updated and modernized for the latest computers. And we've also redone all the music so that where previously they required MIDI equipment to do music, we've now resynthed and reorchestrated all the music so that it's now digital music and sounds really good. So worth checking those out if you play video games on your RISC OS computers. Moving on to hardware, which tends to be what I seem to spend a lot of time doing recently. Our main focus has been what I referred to earlier, our Project N.Ex.T for the last year or so. And Project N.Ex.T is all about delivering high-speed storage and fundamentally improving how RISC OS tackles the handling of disk storage, period. Fundamentally, well, not fundamentally, we focused on what's called NVMe storage, which is the sort of successor to SATA SSDs that you may have had in previous generations. So in terms of a sort of hierarchy of performance, you've got the humble SD card at the bottom somewhere. Above that, you've got what's called eMMC, which is found in something like the Pinebook Pro. It's faster but similar to SD cards. Then you've got the SATA SSD, and then you've got the NVMe as the top of the crown. Now, what we've done is when developing the NVMe technology, we decided that rather than just developing an NVMe driver, that would be too easy, we'd actually do a fundamental rethink of how storage is done on RISC OS, because at present, the way when you develop a new storage driver, you pretty much have to reinvent the wheel every time. So every filing system reinvents. If you want to do partitioning, they have to reinvent that. If you want to, you have to reinvent new filers, basically every part of the filing system stack has to be redone every single time. So it's quite a palaver for anybody developing a file system, and essentially means we have multiple. If you look through the history, there's probably at least a dozen different implementations of partitioning across different interfaces and what have you, and none of them are particularly compatible with each other. So what we've tried to do is create a standard architecture called block devices, which is based on how the Linux platform handles disk storage. And block devices is essentially an extensible and plug-inable system where you have the core block devices as the sort of central core, and then things fit into that to add extra functionality to anything else that uses block devices. So you could have while developing it, the programmer developed a RAM disk that was based on block devices, for example, that allowed him to effectively develop an NVMe simulator, for want of a better term, using RAM. And just plug that in, and every feature of block devices was then usable by this sort of RAM disk-based test harness. So by having this extensible, you create a system where not only does the NVMe driver benefit, but anything we do in future can also benefit. And while we're at it, we tackle the big problems of RISC OS storage. So block devices is fully 64-bit aware. We can deal with drives larger than 2 terabytes. We can use partitions on those drives. Those partitions are standardized. We use the GPT partitioning method, which is used by any 64-bit modern computer system. And RISC OS can handle that. And because it's baked into block devices, anything that plugs into block devices can handle that in future. They don't need to reinvent that. And block devices is open source, so there's no reason why people can't continue to use that themselves. It's free, it's documented, it's available online. With the partitions, we support both Acorn format partitions and FAT32 partitions. So if you look on this Hydra that's on the screen, in the bottom corner, you can see we have a FAT32 partition and the NVMe 4. Those are two partitions on a 500 gig NVMe drive. If you're curious, if you look on the bottom side of it there, that's this NVMe drive right here. Future projects for block devices could include things like RAID, where you would have multiple different block devices, which can be mixed and matched with any block devices you happen to have, working together to provide multi-disk RAID level security. So you could do RAID mirroring, etc. On top of that, we've been enhancing the raw performance of our NVMe driver, and we've now got to a point where basically it's more or less sort of RAM disk level performance. I mean, you're never going to quite get that with any kind of non-memory device, but we're at a point where the limiting factors are now hardware stroke operating system, not the NVMe driver and technology. So if I show you copying files to the RAM disk, for example, if we go to media and we take a couple of videos, I'm going to have to use a couple of videos because it's too quick otherwise. So this is sort of several hundred megabytes of data. Boom. And if I copy it just from, say, from one partition to another partition, let's delete those copies. So that's copying from one partition on the drive to another partition, and you saw that several hundred megabytes of data, zoop, straight across. And essentially, what that means is that where something like a Raspberry Pi would be measured at sort of, at the most 10 or 20 megabytes a second, the benchmarks on the NVMe driver now show sort of 350 to 400 megabytes a second. So it's a huge boost over the storage speed of, say, a Raspberry Pi 4 with an SD card. You might think that an SSD with a Pi 4 using a USB link might be faster, but ironically, there are times when it's actually slower due to how the USB subsystem works. So basically, if you want to use high-speed storage on a Pi-like device, then you want to be using an NVMe device with a compute module. It's pretty much the only way to get a decent level of high-speed performance through in a modern and sensible manner. Sorry, my brain has just gone out of my ears. Well, why might you want high-speed storage? Well, I mean, the most common real-world example is something like email, which is a giant disk-based database. And having high-speed storage for something like that means that emails, mailboxes and things open very quickly. When you send attachments, they just come and go more or less instantaneously. Whereas if you do the same thing on an SD card, it really is quite painful. Similarly, if you run sort of big programs like Iris, if we load Iris on the NVMe machine, you can see it goes to the icon bar, not quite instantly, but more or less. We open a new window. I'm not network connected here, so I can't click on anything there, but you saw how quickly things opened. I mean, basically, Iris opened more or less like NetSurf would on other machines. It makes programs like Iris feel, usable. And that's what this is all about. And this is important as well because we're at sort of a pinnacle for 32-bit RISC OS. Future generations of processor are 64-bit only, and RISC OS isn't apparently going 64-bit anytime soon. and we're sort of probing what's possible, but it's certainly, I don't think this is something that's going to be solved in the immediate term. So as far as running the software that you know and love, we're at a sort of pinnacle of what 32-bit RISC OS is. So if we've reached a pinnacle in processing, we also need to then reach pinnacles in storage and network and video. And that's what we're working towards now. So if you look at something like the Hydra, or indeed the 199-pound mini Pi system that we do, it provides across the board roughly 3 times performance over something like an IMX6 machine that a lot of people are still using as their daily driver computer. So, you know, you've got twice as much RAM, the number crunching, loading when you're running Iris and things, about 3 times faster. Your storage jumps from sort of 100 to 150 megabytes a second up to 350 to 400 megasecond. Your Ethernet is dramatically faster, helped by more bandwidth to the Ethernet controller and faster processing in the computer itself. You've got 4K graphics rather than 1080p type graphics. So, you know, each area of the computer system is lifted up to a level that is in parity with each other, and a big step up from what went before. And as I say, because we're at this sort of pinnacle point, now we're trying to make sure that we can extract every drop of performance in all of the subsystems from the hardware that we have available. So that's what Project N.Ext is all about. Hopefully, it makes some kind of sense. What I'm showing has been available since the beginning of the year, and it comes as standard in all of the machines in the N.Ext range. And we've also made sure that the N.Ext computers are upgradable between them, so you can buy an N.Ext box and upgrade that N.Ext box to the specification of a Hydra, just by effectively paying difference in price to buy the extra components to plug in. And one of the things we've done since the launch of the Hydra last year is to introduce support for Raspberry Pi 5. So we can now have Compute Module 5 in the Hydra, where previously it was all Compute Module 4s. And this has allowed us to incorporate faster processing for the Linux component of the Hydra. So if we look at the Hydra desktop, so this is the Raspberry Pi Compute Module 4 system. And we can sort of you know, so this is click the wrong button. Not my day. It would help if I made the window a little bit to 100% so I could actually see what I'm clicking on, but so that's the Compute Module 4 head, but we've added in Compute Module 5 head. So if I go to the hot list, you'll see Hydra Linux 5. And this is the Raspberry Pi 5 head, Compute Module 5 head. And so there we have, that's got Wi-Fi on that particular head, so it's connecting to the hotel's Wi-Fi. And you saw that quickly brought up content in Chrome on there. So you can access things like Chrome from within your RISC OS desktop. If we go to, not the most happy of stories, but you know, we can, he said boldly. So we can watch the little video clip, etc., through Chrome on our Hydra head with Pi 5 system. But But of course, the it's nice to have the Compute Module 5 head running in the Hydra system as an upgrade that can be added into an existing system. But it's a great shame that the Compute Module 5 is not, there's no RISC OS for Compute Module 5, so you can't run RISC OS on it. But eagle-eyed people may have seen that there's an Enter RISC OS icon on the desktop there. So what could that do? Well, let's find out. Oh, it's RISC OS Direct running on a Compute Module 5. So you might think this might be running on RPCMU or something, but no, this is RISC OS running on a Compute Module 5, thanks to what's called RISC OS for Linux. And if we go to hard disk 4, and we go to, I think it's, I put it in temp and then X, we can run RISC OS mark. Now, on screen this won't look particularly impressive because it's going through layers of sort of remote access to do all of this. But we should get some figures in a moment. And what we can do is we can look at these figures. Where are we? There. Hello. There we are. And what we can do is we can run NetSurf, which I managed to get working. It took some fiddling, but we got it working. And we can do a quick search for, where's my keyboard? Here we are. We can check Chris Hall's how fast comparisons. Oops. Here we are. So if we look at the example benchmarks for, say, a Raspberry Pi 4, we can see that the processor rating, 2,506%. And our Compute Module 5 is running RISC OS at 3,800%. And if you follow those numbers down the column, I won't do each one here for you now, but you'll see that practically every number is sort of ballpark twice as fast as a Raspberry Pi 4. So RISC OS is clearly flying on the Compute Module 5, and we're running RISC OS applications like NetSurf. We can't do sound, and there are certain games and things that don't work, often because of the sound, and there's certain limitations like no VFP. That's a vector floating point. But fundamentally, we can run our RISC OS applications on the Compute Module 5, which bodes well for the future. And we can see that when we do so, we get excellent performance. So if you've got any tasks that require some number crunching, for example, maybe you've got your own programs that need to grind through something, then sticking them on a Compute Module 5 head and then running them through here will complete probably twice as quickly as it would under a Compute Module 4 or Pi 4-based RISC OS computer. So there's clearly a huge amount of potential here. Even if we are sort of having to access it through a sort of Linux veneer, effectively Linux is acting as a thick hardware abstraction layer between the actual Compute Module 5 hardware and the RISC OS operating system. But it's still exciting to see that where Compute Module 5 and Raspberry Pi 5 might be considered off limits normally, it is possible to use them, and with the power of Hydra, we can do that within the RISC OS desktop right now. You can see that the applications that we're running on it are the same applications that you would run on your RISC OS desktop. Hold on, what's going on? There. Oop. Oop. I have a nasty feeling I've killed it. What's going on? No, we're still alive. Why are we not responding? What have I done? Demonstrations, eh? Whatever you do, they always get you. Well, I'll move swiftly onwards. Point is, Compute Module 5, now available in Hydra, also available as an upgrade for existing Project N.Ex.T computers. The only one you can't fit it to is the little mini one, because the little mini one is simply too small to put an extra head in. If we could make it bigger, we could probably put another one in, but only one head for the little tiny one. But the other N.Ex.T boxes and Hydras can all be upgraded with Compute Module 5s right now. Final thing to mention is something that we've launched just this last week, which is what we call N.Ext It Yourself. And that's basically a DIY kit for N.Ext users. It comes in a bit cheaper than buying a full computer, but it gives you the motherboard, a 256 gig preloaded NVMe drive with all your, basically the full software suite from a N.Ext computer, a boot card as well. It's all preloaded onto the motherboard. All you need to do is literally push fit a compute module onto the board, plug in the power, turn it on, and off you go. And that we call that N.Ext It Yourself. And if you can't justify the cost of a full N.Ext box, then perhaps you can sort of afford £100 less, get yourself the DIY kit. So, yeah. Does anybody have any questions about the things that I've been demonstrating and talking about? I know it's probably not the most exciting talk I've ever done, but it's been a few months. If you know me, our personal circumstances this last few months, it has been a bit fraught. So, did anybody want to ask anything? Yep.
With the Compute Module 5,
yep.
It seems to run very, very quickly.
Yep.
But would it run impression through Emula?
I don't believe there is a version of Emula yet for it, but I would have to ask Adrian, and I haven't asked Adrian the specifics. But that, I would imagine that would be another. Sorry, I'm sorry. Bruce Ray. Okay. So yeah, I mean, as I said, there are limitations of going RISC OS for Linux, and that would be would arguably be one of them. Yeah. Anybody else with a question? Oh.
It's about the Hydra and the Compute Model 5 and the Compute Model 4. That's a Hydra running at the moment we're looking at.
Yes.
And you're running the...
I've got 3 heads in this particular one.
Okay.
There's a RISC OS head.
Just that you're running the 5
yes.
Via VNC.
Yeah.
Can you run it directly? You can only run one head directly, can you?
You can only run the one head directly.
Okay.
You can choose. I mean, you could, if you wanted, you could have a Linux head as your main head. But I figure most people here would like to have RISC OS as their main head.
Okay, but if you had the 5 as the direct head running RISC OS inside it,
yes,
you wouldn't have the VNC lag.
No, you wouldn't.
Okay.
I think the point was that RISC OS doesn't run on 5, therefore natively.
Well, the RISC OS for Linux does, and that's what I was showing. So basically, if you ran that as your main head, you could run the RISC OS for Linux on that head and get the performance of that natively. And then you could run other RISC OS heads through VNC. Yes. I mean, whatever floats people's boats at the end of the day. As I say, I'm guessing that a lot of people in this room tend to prefer RISC OS native heads rather than Linux. Well, people have different definitions of it. I've learned not to. I might agree with you, but yeah. There was another question at the back. Doug.
Right. this isn't about what you've talked about, Andrew, but more a thing around music CD.
Right, yeah.
One of your applications. The built-in Acorn CD application, because the free CD information database has changed yet again. You can't actually pull down any sort of track listings anymore.
Oh, right.
So it was one whether there was any potential work on that, because some people still collect CDs.
Yeah, I mean, to be
Yeah.
honest with you, this is the first I've been notified of the
okay.
of changes, so I didn't know that it had changed
Yeah,
yet again.
I just tried it a couple of days ago, and
Okay,
I
I mean,
meant to.
last time I checked, it had moved, and we did accommodate the move.
Yes.
But if it's moved again or changed again, then I don't know.
Yeah. Okay.
Sounds like I've got to do some investigation.
Yeah. Okay. Excellent.
Interesting question, though. Anybody else? Okay. Well, hopefully there was something of interest in there for you. And if you have any more thoughts or questions, you know where the R-Comp stand is, and I'm happy to talk or talk your ears off, if you know what I mean. Thanks for listening.